Alright, welcome back everyone. Today we're going to start something new. It's LeetCode's 30-day challenge, and this is day 1, so hopefully you'll see 30 more of these. And day 1's challenge is single number. And the input we're given is an array, and in this array, every number appears twice except for a single number, and that's the single number that we're going to output. So here we output 1, and then here we have a pair of 1s, a pair of 2s, but no pair of 4s, so we output 4. To solve this problem, we actually just need to XOR each number. But to understand why this works, we're going to dig into that a little bit more. So exclusive OR, if you haven't seen it before, it's basically another operator, like add, minus, stuff like that, but it works on bits, so zeros or ones. So in this case, if we have 0 and 0, then the output is 0. If we have 0 and 1, they're different, so the output is 1. 1, 0, output is 1, and 1, 1, the output is 0. So basically, every time that the A and B are different, then we output a 1. If they're the same, we output a 0. So when we do this in Java, we don't have this symbol. We use this instead. It's like a upper caret kind of thing. And what it does, it does a bitwise operation. So given two numbers, so for example 3 and 4, we convert 3 into its binary representation, so it's zeros and ones, in which case this will be 0, 1, 1. 4 will be 1, 0, 0, and we do exclusive OR on each of their bits, so it looks something like this. 1, 0, 0. And then here they're different, so it's 1. 1 and 0 are different, so it's 1. 0 and 1 are different, so it's 1. And this turns out to be 7. Now we're going to be using a couple of cool properties of exclusive OR that will help us with this question. Alright, so the first property is that if you do 0 with any number, you get that number back. So for example, if we have 0, 0, 0, and 1, 0, 1, if we try to do this, 0 and 1 are different, so we have 1. 0, 0 are the same, so it's still the same. 0, 1 are different, so we get 1. So we get the same number back. So that's the first key. So this is a 0. The other property we're going to be making use of is the fact that if we have something like A, B, C, so if we do a lot of them, that's not good. If we do A, B, and then we do it with C, this is the same as if we just revert the order. Order doesn't matter. It's similar to adding. So if you have 3 plus 4 plus 5, it doesn't really matter if you do 3 plus 4 first, or if you do 5 plus 3 plus 4, they end up being the same number. So that's the second property that we're going to use. And the last one that really makes this, that really takes it home, is the fact that if we do something like A exclusive OR with A, we actually get back 0. Let's try an example. If we have something like 1, 1, 0, and we exclusive OR it with 1, 1, 0, they're the same. 1 and 1 are the same. 1 and 1 are the same. So how do these three properties help us solve the question? Well, let's say we have something like, for the example, we had 4, 1, 2, 1, 2. And I'm claiming that we can just do 4, 1, 2, 1, 2. and this will give us the output that we want, which is 4. So how we get there is if we use the fact that we can reorder any of this, you can see it that we can reorder it as 1, 1, 2, 2, and 4. And from the other property that tells us if you exclusive OR, this becomes 0. This becomes 0. So what we eventually end up is 0 and 4. And then from the first property that we mentioned, anything exclusive OR with 0 gives you it back itself. So that's why we're going to be using exclusive OR. So the actual coding part of it is pretty simple. We just loop through each number. We take track of some output, and then this output will basically exclusive OR it with the number, and then we can return the output. So that should give us what we want. Let's check. Alright, submit. And nice, accepted. So yeah, that's day 1. Hopefully we get through all 30 of them, and we'll see you on the next day.